So today we are going to be trying to pop through an accelerated unit because of PSATs this morning, really shortening our period. I have about 28 minutes, I would say, to teach you this stuff. Talking about exponential equations using logarithms this time. Now, we've done exponential equations before, but when we did them, we had to play games and make sure the bases on both sides matched, right? Because then we could say, oh, once the bases on both sides match, we can just forget about the bases and we'll just set the exponents equal to each other. Well, now we're going to be doing some exponential equations using logarithms. The first one's really straightforward. It says solve the equation 2 to the x equals 30. And they say exactly. That means don't touch a calculator. You go, okay, well, my job is to isolate x, right? That means I need to get rid of that exponential base 2. How do I pull that off? Yeah, you're just going to do log base 2 of both sides. I'll show that step. So we'll do log base 2 of 2x equals log base 2 of 30. And on the left side, log base 2 cancel exponential base 2, and you're left with x equals log base 2 of 30. There's Drew. Boom, done. That's an exact answer. We know that answer is a little bit less than 5, just a hair less than 5. Yeah?
Unlike the IB thing, we need to show that process.
It's good to show it, but it's not necessary all the time. It's just good, just in case. Cool?
Will they realize what we're doing right there? If we put like the log 2 on both sides?
No, that's exactly, that is an operation. I didn't make that up. No, that's a true math operation. That's another thing. It's like in Algebra 2, when you're doing these, you don't see these things as being an operation, but they literally are. You have to do it to both sides, just like adding 3. You know, it is an operation. It must be done to both sides. So, and you guys cool with how I knew the answer was just a little bit smaller than 5? Because 2 to the 5th is 32, and that number's a little bit lower than 32. Okay, just making sure. Okay, more exact answers, meaning don't touch that calculator. Well, part A is just like the very first question, trying to isolate x. So I have to cancel exponential base e. What cancels exponential base e? ln, because log base e, right? So ln. Again, I will show the work just so we have good notes. In case I've, ever monetized these or something on YouTube. It was good. ln of both sides. And it literally is the ln of both sides like that. But I wonder if I could get fired for that. You think I can get fired for monetizing my notes?
No, no college professors do it.
Yeah, but they don't work for public institutions. They work for universities. I don't know. Well, there you go. ln of 30. There you go. I bet you that number's somewhere around 4. I'm not sure because it's hard to raise 2.7 to powers in my head. And it would do it some more. I mean, this is really straightforward, I think. Once you understand what logarithms are doing, got to isolate the x, but it's stuck in the exponent position. Got to get rid of the base. Oh, I can't get rid of the base first because there's a number in front. So first things first, divide both sides by 3. So e to the x over 2, it's kind of grainy, is 7. Now, just like we did in part A, at this point, we cancel our exponential base e with ln, with log base e. I'm not going to show that step this time. This time I'm just going to say that gives me x over 2 equals the ln of 7. And then lastly, multiply both sides by 2. So you get x equals 2 ln 7. But we might as well go ahead and say that's the same thing as saying the ln of 49. You might as well say it. Because we can take this 2 and put it in the exponent position. Now, either answer is correct. An IB wouldn't, unless they were specific about the format of their answer, it wouldn't matter. You wouldn't have had to do that. It just makes for good notes. What do we think? Pretty good? Not bad, right? Now, the next one we will have to use a calculator for, so let me grab scientific calculator here. So we're going to have to solve for x, and we're going to have to get our answer to 3 sig figs. All right. Because here's what's up. These two sides of this equation are not the same base. And unfortunately, they're not both powers of some common number. So yeah, there isn't anything I could do by hand that's going to be pretty. Except for logarithms. In my opinion, logarithms are gorgeous. So what do? Well, normally our process is to cancel an exponential base with the matching log base, right? But that won't really do us any good because my bases don't match. So if I use log base 2 of both sides, yeah, I'd have x minus 1 on the left. But I would have something ugly on the right because log base 2 isn't going to cancel the base 6. And same logic for using log base 6 of both sides. So what do? Well, what we do is use the exponent law. The reason why I just reviewed with you that you could move numbers from the front to the exponent position and vice versa. How about I just take the common log of both sides or the ln of both sides? It actually doesn't matter. Just choose one. It doesn't matter because they change a base. I like common log. So what I'm going to do is I'm going to just take the log of both sides. You see, now the arguments have an exponent in them, which means you could take that exponent and scoot it to the front of both sides. So on the left, we have x minus 1 times the log of 2. Ooh, I don't know what just happened to my brain. Log of 2 equals x plus 2 times the log of 6. Log of 2 is a number. Log of 6 is a number. And whenever you have numbers sitting on the outside of parentheses, what can you do? Somebody said it. Distribute. That's going to give me x times the log of 2 minus log of 2 equals x times the log of 6 plus 2 log 6. Since we're trying to solve for x, what you would do at this point is gather all your x's to one side and anything without an x to the other side. So x log 2 can stay put. I'm going to subtract x log 6 from both sides. And on the left side, I did have that minus log 2, so I'm going to go ahead and add it to the right side. And I have log 2 plus 2 log 6. You see, I just brought everything with an x to the left, and anything without x, just sent it over to the right side. And we can get x kind of by itself right now by factoring. You see, x is the GCF on the left side. So if I pull an x out, I undistribute this x, it's going to give me log 6, log 2, excuse me, minus log 6. And over here, these things don't have, well, they can be combined, but I'm going to hold off on that just for a quick second, all right? Just going to hold off on it for a quick second. Instead, before I can combine them, I'm going to need to move this 2 to the exponent position and call that log of 6 squared or log of 36. Comfortable with that? Okay. So on the left side, I'm going to go ahead and condense this log 2 minus log 6. Because when you subtract two logs that have the same base, and those do have the same base, they're both base 10. It's going to be log of 2/6, which is 1/3. Oh, it's already white. On the right side, because there's addition between those two logarithms, I'm going to multiply their arguments. So that is log of 72. Last step. Last step as far as getting x by itself is to divide both sides by log of 1/3. So I have x equals, and log of 1/3 might be kind of a pain in the butt to type. It might be kind of a pain in the butt, unless you like stack fractions and messing with exponents and stuff. Sidebar. Instead of saying log of 1/3, why don't I say log of 3 to the negative 1, which is the same thing as saying negative log of 3. Now there's not a fraction inside a fraction. It'd be easier to type. And that negative sign, it doesn't matter if it's on the top or the bottom of the fraction. So I'm just going to write negative log 72 divided by log 3. That is your answer without a calculator. That's the prettiest way to write it. You could write it as log base 3 of 72, undoing change of base, but who cares? Because we were told to get it as a decimal, so let's see. Negative log 72, close my parentheses, divided by log 3, close my parentheses, is how many sig figs? Did it say 3? 3 sig figs is negative 3.89. Wow, that was a lot of fun. If you'd like to ask me any questions, though, feel free. I used a lot of properties of logarithms. Yeah, what's up? Which one? Which side? The base 2? Yeah. So if we wanted to cancel base 2, obviously we'd use log base 2 of both sides. Okay. Right, so you'd have x minus 1, and on this side you would have log base 2 of 6 raised to the x plus 2. Right, so x minus 1 equals x plus 2, log base 2 of 6. You see, you'd still have to distribute the log base 2 of 6, and you'd have to gather all your x's to the left side. So I don't think it would have been any faster. It would have gotten you to the same answer. I don't know if that would have been less work, more work, less. Well, let's see. I'm going to skip some steps. I'm going to do them in my head. So x minus x log base 2 of 6 equals 1 plus log base 2 of 36. And this is x times 1 minus log base 2 of 6. And 1 plus log base 2 of 36. And to get it by itself, you would have to do division. So 1 plus log base 2 of 36 divided by 1 minus log base 2 of 6. And I guarantee you, if we continue to manipulate, these would be the same answer. Because the one, both of the ones can be called log base 2 of 2. So the top would be log base 2 of 72. The bottom would be log base 2 of 1/3, which is exactly what I had a little bit ago. So yeah, those are equivalent answers. So I would suggest, it depends on how the IB question asks you to format your answer. If it said solve by hand, and it said it wanted the final answer written as a single logarithm, I feel like that method might have been a little bit more work. And this one would have been easier to say negative log base 3 of 72, but I don't know. And you know what the nice thing is? It doesn't matter. Being able to manipulate them is all that matters. Let's head to the back eventually. There we go. Yay! I love questions like this because they blend some of my most favorite things: exponentials, logarithms, and factoring. Yeah, buddy. You know what I noticed about the number 8 to the x and the number 4 to the x? They're both base 2. They're both base 2. So I could rewrite this as 2 to the 3x minus 5 times 2 to the 2x. Oh, still equals 0, of course. maybe it's difficult to see, so I'll write it in a different way. 2 to the x cubed minus 5 times 2 to the x squared. It should be easier to see now how to factor this. 2 to the x squared is a GCF. It factors. And what it's going to leave me is 2 to the x minus 5. And then you just solve for x. The way we do that is by setting both of the parts equal to 0. So the first one says 2 to the x equals 0. And the next one says 2 to the x equals 5. So we have to solve for x. So let me ask you a question. 2 to what power equals 0? Oh, good. Nobody said 0. None. This is impossible. You can't raise a number to any power and ever get 0. Unless, of course, you were raising 0 to powers. So that's not possible. 2 to the x equals 5. How do we get x by itself? Log base 2. So x equals log base 2 of 5. Finished. If the factoring step was tough on your brain, you could always make a simple substitution at the beginning and say, how about I say 2 to the x equals m? So it would have said m cubed minus 5m squared. If that is easier for you to do, by all means, do that. Because then you go, oh yeah, I see m squared, and then m minus 5. So m has to equal 0, and m has to equal 5, and then you could resubstitute back in your 2 to the x equaling 0 and your 2 to the x equaling 5. If that's better for you, then please do that. I just want my students to do whatever they need to do to get full credit, of course, without cheating. You know, gotta get there honest. But if you'd like to ask me anything, please go for it. No? Okay. Find algebraically, that means don't cheat and use a calculator, the exact points of intersection. That means your answers are either going to be integers, or excuse me, your answers are either going to be rational numbers. I shouldn't even say that. Your answers will be numbers you can find algebraically. Let's go that route. Or they are logarithms or something along those lines. But you're not going to be able to give us a decimal answer. Can't give us an irrational answer. It says check your solution using technology. I'm not going to bother. I'm going to be real with you because our algebra skills are strong. Find the points of intersection means set them equal to each other. And solve for x. IB likes to do this thing to people. What do you think? Let me hear some thoughts. How would you try to go about solving this? Thoughts?
No idea.
Well, I mean, if I just said go, you know,
I'd add the 3 to
Just
both
give up.
sides.
add three
I
to
don't like it.
add 3 to both sides
Yeah.
because you don't like it on the left.
I just don't like it. I'd rather have everything together.
So maybe get the e's together and then not. Well, here's the problem though. They have completely different exponents. They're not like terms. So you're not going to be able to pull it as a GCF right now. I mean, that normally would be the strategy, right? Get all the e things to one side, maybe pull e to the x as a GCF or something like that, but shucks, shoot, darn, one of them has a negative exponent. What do you think?
Wait, so, all right.
Let me hear it, Zach.
This is conditional based on whether what I'm thinking applies to mathematics. So, wait. No, I'm dumb. Never mind.
No.
Yeah, I'm wrong.
See, I wish that we could have followed that thought train with him because it seemed like an interesting journey. Okay, one more try, Chris. What do you got? Yeah, that's what we're doing here.
Add 3 to both sides.
Okay.
And then natural log.
And then what?
And then take a natural log of both.
Here's the problem, though. Remember, you can't cancel exponential bases just like logarithms until they're alone on that side of the equal sign. So if you added the 3 to the other side, you'll have 4 minus 3e to the negative x. You don't have an exponential that's sitting alone.
Can you do it right? Like have exponents on that side?
I'm sorry?
Can you do it like so? Like you know how if you divide, say you have 3x equals 2y plus 3z,
Okay, that's a lot of variables, but okay.
and then you divide everything by 3 because of the 3
Yeah.
on the left side. You can still do it though if you do it to everything.
You can't do that with logarithms, though. Because remember, there's no rules that split logarithms apart that have adding and subtracting in the argument. And that's the problem here. You can only split logarithms that have multiplication or division in the argument. I tell you what, let me rewrite this thing in a slightly different way and see if your brains catch it then.
I figured it out.
Okay, Zach, moment of glory, what do you got?
Okay. So, all right. Okay, wait, I just. Okay. All right. You can rewrite the 3e to the negative power of x
Yes.
as 3 over x, or 3 over e to the x power.
Let me write what he just said. Okay, Zach, now what?
All right. From there, all right. So you can just to make things simpler. I can also bring the one. I transferred the net minus 1 on the thing. We're gonna rid of the 3. Make that a minus 4.
Okay, I'm gonna not what? Okay, yeah, sure, whatever.
I just don't like it being
Okay,
combined.
he doesn't like it there. It's fine. We'll subtract 1 from both sides.
All right. Then all right.
He's so close.
Yeah, I'm lost.
Okay, someone help him.
Doesn't negative sign, can you move that as a -1?
That's in front of the fraction? No, because that technically means like -3 right there. So that's like -3 over e to the x. Ashley B.
Okay, this is like crazy.
No, it's not.
Probably,
Let me hear it.
you multiply like that e to the x that's not a fraction by the e to the x on the bottom?
Oh, you mean we cancel fractions by multiplying by the denominator?
Yeah.
So what we're going to do is multiply both sides, actually multiply everything by e to the x. Because when you do that, this will no longer be a fraction. Is this the last thing on this page? Good, I have space. What that's going to give us is an e to the x, crap, is that your bell? No, it's not. It gives us an e to the x squared, because that was the first bell. There's always a bell during our class, right? Yeah, that was a lunch ending. Okay, that gives us e to the x squared minus 4e to the x equals -3. So it's a quadratic. You have to bring everything to one side. It's a quadratic exponential. I didn't make this question up. Again, you could make the substitution that m equals e to the x if that's easier for you. I'm just going to go ahead and factor it. I'm looking for two numbers that multiply to 3 that add to -4. Yeah?
Why did you bother multiplying the e to the x out, or like distributing it out? Couldn't you have just left it there and then solved for that?
Oh no, you have to distribute it to all the parts because the left side has a plus or minus on it. Like,
Yeah, but I just left it as e to the x outside of e to the x minus 4, and then solve for it.
but it equals -3 though. Doesn't equal 0. Yeah, no, that'll get you. It factors. Here, here's what you're thinking, remember? M squared minus 4m plus 3. That's what you're thinking. The two numbers that multiply to 3 and add to -4 are -1 and -3. So we have e to the x minus 1 times e to the x minus 3 equaling 0. That tells us that e to the x has to be 1 and e to the x has to be 3. The first one. E to what power gives you 1? 0. Everything to the 0 power gives you a result of 1. And e to the x equals 3. Got to cancel the base e using natural log. So you natural log both sides, and you get x equals the ln of 3. And because we were dealing with exponentials and not logarithms, we don't have to go back and make sure that we haven't broken the rules of any domains, because exponentials don't have issues like that. They have restricted ranges, not restricted domains. Mic drop.